The numerical aperture, NA, of an optical fiber is a crucial parameter that determines the ability to capture light and the acceptance angle of the fiber. It is a measure of the fiber's ability to capture and transmit light.
The video is organized as follows. Abstract. Experimental manufacturing and assembly. Theoretical results. Experimental results. Conclusions.
Numerical aperture is a measure of an optical fiber's ability to collect and transmit light. It is defined as the sign of the fiber's maximum acceptance angle, i.e., the angle at which light can enter the fiber and be transmitted. Why is numerical aperture important in fiber optics? Numerical aperture is important because it determines the amount of light that can be transmitted through the optical fiber. The larger the numerical aperture,
the experiment was carried out using an experimental setup that included as main materials a laser light source, ENE laser, 60 cm of single-mode optical fiber, a power meter, and a digital detector to capture the light at the other end of the fiber as seen in video. The single-mode optical fiber was placed in the system, undergoing angular variations thanks to the rotation stage once it was positioned, and measurements of the propagation of light through the fiber were made using the power meter.
From the assembly carried out and considering the angle of incidence at 0 degrees as the central value to take the measurements, then rotating the rotation stage 2 degrees to the right and 2 to the left, the following experimental data observed in Table 1 were obtained.
These data were plotted in MATLAB, yielding the diagram shown in Graph 1, where the behavior of the transmitted power is a function of the angle of incidence for the red light source, which schematizes a Gaussian behavior. The results obtained showed a numerical aperture of the single-mode optical fiber used of 0.05. This result is consistent with the reported literature, which indicates that, for a single-mode fiber, the numerical aperture is usually of the order of 0.1, but can vary approximately between 0.05 and 0.4. This indicates the fiber's ability to capture light from at this range of angles, and therefore its efficiency in transmitting information through light.